Friends, welcome to my YouTube channels. So today we are going to discuss the convection problem. So first I taken one problem, sir. A vertical plate of 0.7 meter wide and 1.2 meter height maintain at a temperature of 90 degree in a room temperature of 30 degree. Calculate the convective heat loss. Once they given convective heat loss, that means this problem is known as convection problem. So this is heat transfer problem, but this is convective heat loss asking. This is the problem for the convection. Now convections already we discussed. We have two types of convection: forced convection and free convection. So forced convection, now if velocity given, then this problems will be forced convection. If force not given, this problem will be the free convection or the free convection problem or natural convection problem. So now in this questions velocity not given. So that means this question is convection problem, but this is nothing but free or natural convection problem. So here that steps I wrote, that is steps how we'll solve this question, that all steps I wrote here. So when velocity not given, that means this is the called free convection problem. So free convection, what is if density difference, change in density is made by the heat transfer, that is known as free convection. So in step to solve free convections numerical, what I have to do? So first work is we will find the film temperature, Tw plus T infinity by 2, surface temperature plus fluid temperature average. So in that temperature, will HMT data book will find the properties of the air like thermal conductivity, density, kinetic viscosity, Prandtl number. These are things we'll find from the HMT data book based on this film temperature. Then we'll check the coefficient of thermal expansion. Coefficient of thermal expansion 1 by Tf. So we'll calculate. Then we'll write the Grashof number formula, G beta L cube delta T by nu square. That means kinetic viscosity whole square. G is gravity 9.81 value. So after finding the Grashof number, we'll find the product of the Grashof number and Prandtl number, and we'll see this status of the fluid, either laminar or turbulent. Suppose this is less than 10 power 9 laminar flow, greater than 10 power 9 will be the turbulent flow. Once we'll know this, either laminar or turbulent, then we'll go the laminar flow. Suppose laminar flow Nusselt number 0.59 GRPR per 0.25. If this will be the turbulent, then 0.10 GRPR 0.330. Finally, this will get H. So Nusselt number will be HL by K. H will find heat transfer coefficient. Then we'll substitute your heat transfer coefficient. We'll go the heat transfer loss or heat transfer. So this is the process I wrote. This all the formula will be there in the data book. This formula and all these conditions and all everything will be there in the HMT data book. So now I will solve the questions, because this theorem always, once you are solving any question, this theorem always you have to go through or you keep it in mind. Now first what I told here, film temperature we have to write. So Tf equal to nothing but Tw surface temperature plus fluid temperature by 2. So it will be 90 plus 30 degrees Celsius by 2. So 120, then 60 degrees Celsius. I know this temperature, the 60 degrees Celsius. Then with that temperature, we'll write the properties of the air. So at 60 degrees Celsius, from HMT data book, we'll write all the value. What we'll write? Tell you density. So density will be how much from this it will HMT data book. If you will take na, it will 42, 43 or 45 page number like this will be there in different editions according to the different editions. So density 1.060 kg per meter cube. Then we'll see the kinematic viscosity. Kinetic viscosity will be 18.97 into 10 power minus 6 meter square per second. This is the unit kinetic viscosity. Then we'll see the Prandtl number PR notations will be PR, Prandtl number at 60 degrees Celsius, 0.696, 696 Prandtl number. Then thermal conductivity also required. So thermal conductivity K is equal to, what is the value? 0.028, 96 watt meter Kelvin. This is the unit. So what we did at 60 degrees Celsius, properties of the air we wrote here. So this here beta, because coefficient of thermal expansions. First we have to find beta coefficient of thermal expansion. This is nothing but 1 by Tf, because this is velocity not given. So you can write here also velocity not given. So this is, so it is free convection. This is free convection. Velocity not given, so this is the free convection. So you can write this. So this is the free convection problem. So free convections, what is there? Na coefficient of thermal expansions we have to find out. Force convection, that steps will not be there. But this also steps will be, force convection also will be there. But thermal coefficient of thermal expansions will not be there. So that will be, how much? This is 60 degree. But this should be in Kelvin. I wrote here, Tf should be in Kelvin. So plus 273 you have to add. So now it is become Kelvin. So how much this value will come? 1 by 3 into 10 power minus 3. So this value is coming 3 into 10 power minus 3 per Kelvin. So this is the K value here. This is the property and all. So this minus 3 into 10 power minus 3 per Kelvin. So this will be the Kelvin. So with thermal expansions we find out. Now we'll write the Grashof number. We'll find the Grashof number. We'll check the status of the fluid. GR is equal to G into beta into length power 3, and this temperature difference, like surface temperature minus fluid temperature, then kinematic viscosity. This is 9.81 into beta. This just now we got 3 into 10 power minus 3. Then length, wide 1.2 meter, height, so length 1.2 power 3 into 90 minus 30 degree. Divide by kinematic viscosity 18.97 into 10 power minus 6 whole square. 10 power minus 6 whole square. So this value will come. GR value will come. Already calculations we did here. So 9.81, 3 into 10 power minus 3, 1.2 length power 3. Then this value is coming 8.4 into 10 power 9. 8.4 into 10 power 9. This value is GR value I know now. Now we'll go the product of GR PR. Then only we'll find the status of the fluid. No? So GR PR, Grashof number, Prandtl number, product I need. So what is GR here? 8.4 into 10 power 9 into Prandtl number 0.696. So this value is coming, GR PR value is coming 5.9 into 10 power 9. 5.9 into 10 power 9. This is the product of the GRPR. Now we'll compare. We'll check the status of fluid. This is 10 power 9. So how much coming? 5 into 10 power 9. So this is nothing but 1 into 10 power 9, 1 into 10 power 9. So now 5.9. So this is greater than, GRPR is greater than 10 power 9. So which is greater than, you can write 9, which is turbulent flow. turbulent flow, which is turbulent flow. So because this is greater than, now turbulent flow, now we have to see the Nusselt number for the turbulent flow. If the turbulent flow, then Nusselt number will be Nu is equal to 0.10, then here GR/PR power 0.333. This is the Nusselt number. This will be there in the data book. If you will go to the page number 144, 143 or 145, different editions, this page number little 1 or 2 page number will be the different. So this value will substitute here 0.10, then GR value will be, GR/PR direct value will be there. So 5.9 into 10 power 9 power 0.333. So this value will come, Nusselt number value will come, how much? 0.1, 5.9, 10 power 9. So this value is coming 179.3. 179.3. This is the Nusselt number we got here. Now we know the Nusselt number is equal to HL by K. So again we'll write Nu is equal to HL by K. That implies Nusselt number will be 179.3 is equal to H I need, length will be 1.2 meter, 1.2 meter. Then kinetic viscosity K, you already wrote here, 0.02896. So that implies H is equal to, you will know, heat transfer coefficient will know now from here. So 1.79 H into 1.2. So it will H coming 4.32. So 4.32. This unit will be watt meter square Kelvin, heat transfer coefficient. Once you know the heat transfer coefficient, calculate the convective heat loss. What is convective heat loss? This is called Q. So convective heat loss. Convective heat loss, that is Q is equal to HA TW minus T infinity. This is the formula is here. Now H already you know. 4.32 area. Area will be 1.2 into width. Height becomes length only here. So 0.7 H, then 90 minus 30. This kept it degree Celsius or Kelvin, no problem, because negative difference will be same either Kelvin or degree Celsius. So this value is coming 0.7 into 1.2, so 217. So that implies Q is equal to 217.7972 watt, 72 watts. So this way we can calculate the heat loss for this problem. So problems you look here, if you know the theorem, if you know the steps, how simple this questions. So like this question, they will ask university exam 12 marks. So what is the steps? First find the film temperature. With the help of the film temperature, go the HMT data book, find the properties of the air like density, kinetic viscosity, Prandtl number, thermal conductivity. Then go the coefficient of thermal expansion. Then thermal expansion nothing beta, because we have to find the Grashof number. So Grashof number beta will be there. So this formula will find the Grashof number. Then product of the Grashof number, Prandtl number, will see the status of the fluid, either laminar or turbulent. So this is more than 5.9 into 10 power 9. Here, see, there are 10 power 9. That means 1 into 10 power 9. 1 into 10 power 9. So this is greater than 10 power 9. So this is turbulent flow. Turbulent flow, now we have to see the turbulent flow Nusselt number formula here. This will be there in the data book only. If you go the free convections, that formula will be there in the 144, 145 page in near. This value will be there. Substitute, find the heat transfer coefficient. Substitute heat transfer coefficient in the convective heat loss. You will get the answers. Okay. So okay, students, see this solutions very carefully. Watch this video. Share this video to your friend and carefully make the notes. Write this problem. Make the notes. This theorem should be with you. Revise twice and thrice. 100% you will get success. Okay. Thank you.